My name is Birkir Guðjónsson. I'm a 29-year-old guy from Westman Islands. I live here in Reykjavik now. That's me in action 15 years ago. I've been building things with computers for as long as I can remember. I work for Bueno. It's a full-service creative agency of 65 people. And we have offices in San Francisco, New York, and Reykjavik. We design and build digital products, brands, and experiences with all sorts of clients, ranging from big, well-established companies and even less-known startups that you probably have never heard of. We also work for some Icelandic clients, you can see in the video, and we also do our own kind of branding elements, like the famous Bueno hot dog. That's enough for introduction. Let's dive into the topic. What can React render, and how can it really do that? According to Wikipedia, React is a JavaScript web framework built by Facebook in 2011. But it's actually not a framework. And it's actually not just for the web. I hope you can see this. Because React has recently been known to be able to render to just a DOM. This is a list I compiled from one of those GitHub awesome lists. And we have everything ranging from WebGL, TV, hardware, audio, and even design tools like Sketch and Figma. So let's zoom on this a little bit. React has a layer commonly known as the Reconciler. And it lives between the user code, the code that we actually write. It's usually written with JSX, and the platform code. And this is lower level APIs like hardware and the DOM, or even native views like iOS and Android. Reconciler is just a diffing algorithm that helps React figure out which DOM elements to update on a state change. So when you change a state, React will update the DOM to reflect. It is the part of React that is shared between multiple platforms like React DOM and React Native. There are two generations of the Reconciler. Throughout the history of React, we have the Stack Reconciler that was built originally for the DOM, and probably the part of the reason it's called a web framework. And later, I think 1 or 2 years ago, we got Fiber, a total rewrite of the Reconciler. Oops. Are we on? OK. So Facebook did a total rewrite of the Reconciler with React 16. And it can perform the reconciliation of the React tree by splitting work into minor chunks. And so it can now prioritize, pause, and resume work. And this is a big thing, enabling like more render targets than just the DOM. Just for kicks, I'm going to show you how it looks under the hood. Here we have an instance of the Reconciler class from Facebook. And it has all these methods that are unpopulated with our own code. What it needs to know is how to create an instance of an object, how to append and remove children from the tree, and then how to deal with state changes. And these are your props from React. You can also tell it how to deal with text nodes specifically, and this comes from the DOM, but applied to different render targets like React Native, where you have to deal with text as well. So if we want to create a super simple DOM render using this Reconciler, this is how we would do it. We have to fill out what we want to do when to create the objects. And in this instance, because it's just a super simple DOM renderer, we just take the type from React and we create document.createElement of whatever that type is, div or button or whatever you want it to be. And then we set the attributes of the DOM element to reflect the props that come from React. And then we describe how to append and remove childs like this. And this is just the classic DOM manipulation methods, append child and remove child that you know from the DOM. We also need to implement how to update props or deal with state changes. And in this case, we just take those props and we apply the attributes to it. And in this case, if it's a text, we just replace the text with a new text. Here I have my React simple DOM imported, but currently I'm rendering with React DOM. So for demonstration purposes, I added my own element called JS Meetup, and it renders the text normal text. But now if I switch to my own React simple DOM, it will render something completely different. And that's because I added a small if statement in my reconciler to output something else, anything I want, like we can see over there. And one thing to note is that all normal React internals like useEffect and useState and so on, they work just as well with any reconciler. Okay, now that we know how to create a very simple DOM renderer, let's see how we can do that with WebGL. Before we go into details about this, let's zoom out a little bit and see what technologies we can use to render WebGL. This is how to make a rotating cube in WebGL. And as you can see, it's a hefty code, about 200 lines just to make that box. It's rather verbose because WebGL works by drawing triangles and lines. So we need like 12 triangles and to form a box, and it becomes very hard to write a reconciler. And it's also very hard because we don't have any objects to map to React. So, but the good thing is the problem has already been solved by the JS community. There is a library called THREE.js that helps us build 3D objects or 3D scenes with 3D objects. You can create boxes and shapes, spheres, and it also helps us with lighting and effects and shadows and so on. And this is the same rotating cube built using THREE.js. So creating a reconciler for this kind of code becomes much simpler because we can map React node to object-like properties like scene and perspective camera, box geometry, mesh standard material, and so on. So while thinking about these three JS objects, this is how a reconciler could be implemented. It's the same as the previous with the React simple DOM reconciler, but instead of returning a DOM element, I return three.mesh, which is a 3D object for THREE.js. Or if it's a different type, I return a different type. Then we can simply append the 3D object to its parent if we need to. The only problem is that in some 3D objects, like mesh in this case, we need to set properties to it. And in this case, we need to set geometry to the geometry property. And we can do that by checking what the parent is and checking what the children is and then just touching it as a property. We also can remove children, and then if we need to do any cleanup, we can do it here. We can dispose of the geometry to free up memory. So when we compare the React code to the left and then THREE.js code to the right, we can see how it maps to React. We have our mesh there, and we have our geometry and material, and you can also see how the props map together. And you can do some processing on the backend if you want to convert the string red to the hexadecimal value of red. We can also add objects like lights and effects and so on. There's already a THREE.js reconciler for React called React 3 Fiber. And this is a demo of the same rotating cube. And as you can see, the code is much simpler. Everything starts from the canvas element that we import from React 3 Fiber, and it will render the children. One thing to note is that I import a hook called useFrame, which is a hook that we can use to inject into the recast animation frame loop, and we can do all sorts of state changes there to reflect on the objects. So the question becomes, what's the real benefit of using something like React 3 Fiber versus just doing it with pure THREE.js? We get lower memory footprint because the render leverages React lifecycle methods. So when things in React unmount, we can free up the memory and clear textures and so on. This is something you'd otherwise have to manually do if you use THREE.js. This is a demo of like thousands of objects. It's actually running right now, real time, with good performance, and it has advanced lighting and everything. Next thing is pointer events. Pointer events are abstracted away with raycasting, which is a built-in tool from THREE.js. And as you can see here, like I can light up each an individual component. The pointer events come as React props, so I can subscribe to them and do some state change. And everything works, has a good performance. And the next big thing is it's cross-platform. So it can render in the browser, and it can also render in React Native. And this is thanks to a lot of work that Expo did by porting WebGL 1.0 and 2.0 to React Native. We also get pointer events, like you can see with the Lorem demo, multi-touch and everything. And last but not least, and in my opinion, the biggest benefit is it can participate in React's near infinite ecosystem of components, tools, and add-ons, many of which are cross-platform out of the box and can directly operate on your meshes and materials. Let's take React Spring, for example. It's an animation library that uses physics instead of time and curve that you're used to with DOM. This is an example how to use React Spring with DOM elements. I just have a uSpring hook over there, and I rotate the box 90 degrees when I press it. And here we have React 3 Fiber using that same hook, uSpring, and I just rotate a random axis 90 degrees, and it just works cross-platform. The same goes with React Native. Everything just works. And because pointer events are replicated as DOM events, we can use libraries to deal with those events for free. For example, React used gesture that translate pointer events to gestures like swipe and scroll and so on. It can be hooked up with React Spring and React 3 Fiber, like in this demo. This is like a low poly football kind of thing that I'm tracking around, and this is the complete code to do that. Like everything becomes super simple, but at the same time very declarative. And adding physics can be as easy as using a webhook, or not webhook, sorry, just a React hook. This is a physics engine called Cannon.js that we just import using a hook. So combining everything together, we can create an experience like this. This could be a train selector experience where you have to pick your seat. And as you can see, I have multiple cabins, and each cabin has a rows of seats, and each row has like multiple seats, and all the props are like colors and the positions and so on. And it starts to be very easy to develop. The development experience is quite good because we have hot reloading and so on. Very cool. Pink seats. Or combining audio, motion, and gestures in a game-like experience. This is a game made by Paul Henschel, the author of React 3 Fiber. He's pretty good at doing 3D stuff. And just for demonstration purposes, I removed all the components from the scene. This is the scene, and I'm just adding the components back in there. And you'll start to see things form like stars and explosions and track and particles, rings, and then I can add rocks and planets and enemies I have over there. And everything just hot reloads. The render loop never stops. It just continues to run. And of course, it's not a game unless we add effects. Boom. That's an easy way to build a game, right? So yeah, at Ueno, we've been leveraging this technology to build awesome experiences with our customers. Útmeða is a project we made with Tjarnagatan. With the aim of the project is to promote improved public health by encouraging people to express their mental well-being and seek professional assistance when needed. Here we leveraged React 3 Fiber to do a video swapping effect and a waveform effect, but everything else is just DOM. So we're not really rendering any 3D objects on the scene. So as you can see here, when I press, I'll form this 3D or like a video effect. These are 10 videos that we can scroll in a timeline. So yeah, React 3 Fiber, you can use it to do other things than just 3D. And earlier this year, we launched a project with our friends at Nova, Snjallheimilið, or Smart Home. The idea was to build an experience where you can see all the different devices that Nova has to offer, smart devices. So the idea was to build kind of a house and in a 3D world where you can see different rooms. It's like a cross-section of a house. And everything is built with React. We have both DOM, and we also have the 3D scene built with THREE.js. And yeah, let me pick some of the products. Yeah, we also have different lightings, baked in textures, and so on. So let me zoom in here. And And this is just regular HTML stuff. Yeah, it's a crazy cat. We also have a nice Easter egg inside here. This bandit, crazy bandit. What's up? We may later do a separate talk on just like in-depth behind the scenes of this experience. There's a lot going into stuff like this. Everything from the designer to the 3D artist, handoff to development, and then like what it takes to actually do this. So stay tuned for that. Yes. Otherwise, I'm done. Thank you. Should we do questions? Yep. Okay. Any questions?
Are the examples you showed accessible somewhere?
Yeah. Are the examples that I showed accessible somewhere? Yeah. I think all of the examples projects that we at Weno made are available on the React 3 Fiber website.
How is a background in 3D animation? How valuable is that? Or can you just like...
The question is how is background animation in THREE.js? How valuable is it?
Yeah, like do you need to know 3D models?
No, not really. You can just start by experiment with all sorts of objects, make them move and so on, and start from there. As soon as you go into it, it's going to be very simple.
How long did Snjallheimilið take to implement?
I don't remember. It was a few weeks. Yeah, I think it was like 4 weeks or something like that.